Doing two variable equations and inequalities. So on Friday we did one variable equations and inequalities. Today's two variables. So there's going to be a y in there. All right? Yeah.
Can we correct that if we didn't do it?
Correct.
Label the lines.
Yeah, you'll get them back today. Did you turn yours in already?
I just turned mine in.
Okay. So didn't you label the lines on them?
No, I didn't.
Okay. So you might want to grab that before I score it today. Not right now. Okay. Okay. So two variable equations and inequalities. You're going to deal with absolute value. We're going to deal with linear. And you'll have the equations and inequalities. I want you to read example 2 on page 83 and try to do number 8 using your calculator. You get about 5 minutes. Here we go. So if you haven't started already, or if you haven't quite finished, page 83, hopefully you've studied the graph there. Now we're going to break down this graph a bit more. I know we've already talked about absolute value before, but we're going to break this one down a little more. But I just want you to really pay attention to the two methods they used. And we're going to go through the third in class. But method 1 is a method you can use with any function. Okay, so as you progress through the years, you're going to see a lot of weird-looking equations, and they're going to be telling you to graph them. As you progress in math, you're going to get a lot of weird different equations, and you have to graph them. And generally, you'll have an independent and a dependent variable, or an x and a y. X, you're independent, y, you're dependent. Okay, so if you know an x value, you can plug that in, and that'll tell you what y is. That's how you can graph anything you don't know. Okay, you just start picking values for x and solve for y, and that's what they've done here. Now, it's helpful if you know where the vertex is, because that tells you where it's going to turn, and it's helpful if you know what picture the graph looks like, because that tells you kind of where to start. And we would know that a little because we've talked about h and k. We should know that our k value is -3 because that's what's being subtracted. That's on the outside. Now the h value is when this thing in here makes 0. Now if you recall from earlier in the year, we talked about we never had a term out here in front of the x, so it was always just the opposite of that. It was like -4. Well, really it's whatever makes this thing equal 0. So 2x plus 4 equals 0. We subtract 4 and divide by 2. If I subtract 4 and divide by 2, I get -2. Okay? Well, that happens to be our hk value. -2, -3. Okay? That's our vertex, which it's nice if you know that. You don't have to know that. Maybe you would end up stumbling upon it if you started at 0, which most people start at for x. They throw 0 in and they start solving. Maybe you'd see that, well, when x is 0, you would get this, and you would keep going this way, and you put a few values in, all of a sudden you'd go the other way. Okay? That works. You could go that process. The other method is to use your graphing calculator, which is really what I wanted you to try to do with number 8. So how many found absolute value again on your graphing calculator? We talked about it a bit earlier on. Okay, number 8, saying graph that thing. -3 minus the absolute value of x over 2. So when we're putting in the 3 is easy, right? But we need to go to our y equals. I need to clear out mine, so I'm just hitting clear. All right, so 3 minus the absolute value of x over 2. And where is absolute value? Math. Good, math. So you got to hit that math key. So for those of you who can't find the math key, that's this guy right here. Okay, and then you arrow over and hit option 1, abs. Now, depending on the calculator you have, if you have an older version, an 83 or an 84 that hasn't been upgraded, it'll just say abs and it'll put parentheses. Okay, that open parenthesis is like your absolute value symbol there. So when you finish putting in this case, you need to put in the x over 2, x divided by 2. Okay, oops. If you have just the abs with the parenthesis, you should close the parenthesis there. If not, you just have that. I know that some of you like using the little fraction option on your calculator, and that's fine. But when you hit graph here, now that's my graph. I've got a zoom feature going, so I'm going to go zoom what?
Standard.
Zoom 6, right? Zoom standard. Now that shows this. Okay, now that's an absolute value we haven't seen before. It's opening down, meaning the absolute value, if you look at our absolute value here, This guy right here is a negative. We rearrange that, y equals negative absolute value of x over 2 plus 3. Okay, that sign goes with that. It's like reading a book. As you read, that's a positive 3 minus x over 2, absolute value of x over 2. That's a negative. Okay, that means it's opening downward. That's what that tells us. It also tells us that 3 is our k value. So if I looked at the graph, you'll notice it goes up 3 on the x-axis, or on the y-axis. And then on the x-axis, this is actually x over 2, which another way of thinking of that is y equals negative. What's another way of writing x over 2? Good, it's 1/2. 1/2 x plus 3. Now what's my k value? What am I adding to that x inside there? What's inside this? What's being added?
0.
0. Or what makes 1/2 x equals 0? What does x have to be?
0.
Everyone set 1/2 x equal to 0 on your paper. Set it equal to 0. 1/2 x equals 0.
Yep.
Okay, what times 1/2 is 0? 0. X has to be 0. Okay, if you're not adding or subtracting anything inside there, then your k shift or your h shift is 0. So your vertex on this graph should be at 0, positive 3, and that's what it is. Okay, you get 0, positive 3 there. Okay, it has a slope of negative 1/2. Now we'll talk about that more here in a minute. Okay, everyone understand how to put that in their calculator? Tell your neighbor what you know about HK. Going to come into big play right now. Volunteer, what do we know about HK? Yep.
K is on the outside of the equation, and that tells you whether or not the line shifts up and down. And then H is the value on the inside of the parentheses, or absolute value. And now it tells you whether or not the entire thing shifts left or right.
Very good. Perfect. And we'll talk about that more in here in a minute. How many of you got something like that? H is on the inside, K is on the outside. How do you find H? For instance, if I give you y equals 3x plus 2, thank you. Y equals 3x plus 2 minus 5. Tell your neighbor how you're going to find H. On?
Well, do you want me to say the coordinates?
Oh, how do you find H?
So H is gonna be it's gonna be negative 2, or like on the x-axis you're gonna have to move it over to negative 2.
Okay, so you're telling me what H is, right?
If it's in the grouping, then you have to switch the sign to a negative to
Okay.
positive.
So what we did last week, we said we had to switch that sign right there. How many agree it's negative 2? H is negative 2. What's the purpose of finding HK here? Yeah.
Find the vertex.
Find the vertex. Just a quick review, and I hope you remember this. So, okay, that's our vertex. The purpose of finding HK is the vertex, the coordinates of HK is our vertex. It helps us find that turning point. Now, how many say it's negative 2? How many say it's not negative 2? Okay, if it's not negative 2, what is it? Cool.
Negative 2/3.
Negative 2/3? Hannah? How many agree it's negative 2/3? How did you find negative 2? It's not negative 2, it's negative 2/3. Quaid?
Oh, what I did is I did 3x plus 2 equals 0, and then I minus 2 from each side, so then I have 3x equals negative 2, and
Okay, so you solve from there, right?
yeah.
Okay, so you set this part, your h value is whatever makes this 0. Remember, if there's a term out here, it's whatever makes this 0. Okay? What's that?
You have to set k to 0 to get h.
Yeah, you mean that.
Yes.
Okay.
Same thing.
Okay, so we're going to find h. We're going to set this, whatever makes this group 0. Then you solve. What are the 2 steps in solving? Tell your neighbor. Okay, volunteer. Parker.
Subtract 2, divide by 3.
Subtract 2, divide by 3. We subtract 2 over. Okay, we're left with 3x equals negative 2. Then we divide by 3. We get x equals negative 2/3. That means our h value is negative 2/3, and our k value is?
Negative 5.
Negative 5. It's always the thing on the outside. That is our vertex. That's going to be a big point of emphasis today. Now let's see if you guys can remember that the whole class. Okay? All right. We're going to try some problems together. We're going to try some problems off our assignment. Example 1, we're going to graph those. While I'm passing stuff out, I want you to tell your neighbor how you are going to graph those two equations. I want you to graph number 1 and number 7. Now your assignment today is the example side all. Okay?
Oh, gosh.
We're not doing the mixed side, so example side all. So you can write that on top. These are 2 problems right off that assignment. So number 1 and 7. So if you are the type A type, that you're like, I can't graph out of order, then number your grids. Okay, if you want to put them in your notes, that's okay. You can put them in your notes and just, when we correct tomorrow, refer to your notes. That's fine as well. That way you can have it in your notes also.
A ruler at home.
All right? Yeah, if you need a ruler, I got some over.
No. Shoot, no,
Very
that's the
kind.
wrong one.
Here we go. Few things. First, this is a linear equation, correct?
Yes, sir.
It's just y equals mx plus b. In this case, when I look at this, this is x. Divide both sides by 3. We get x is greater than or equal to negative 3. Now, you got to think, when you're graphing these, just think of it as x equals negative 3. Graph it like that, okay, with the exception of, think about solid lines or dashed lines. Now recall this symbol here, anytime you have an equal to piece to it, that symbol there, or the equals, those are all solid lines. That means your solution can be any point on that line. These symbols here, those are dashed lines. That means your solution cannot be on that line. Okay, how many remember that? Okay, so remember, when you're finding a solution to an inequality, you're finding a region. You're finding an infinite number of solutions generally. Okay, so when I plot x is greater than negative 3, well, in this case, we've got to think of x equals negative 3. Okay, on your x-axis, that's right here. And remember, if there's only one variable, it only crosses one axis. It crosses that one axis right there. And since it's a greater than or equal to, it's a solid line. So there is my line. If there's only an x, it's only going to cross x. And then you have to start. Well, Dylan, question?
Yeah, I'm confused because like yesterday, or on Friday, we had when we found inequalities, they looked like that, but we just did it on that one line.
Yeah, so we could do this just on a number line, right? That's what I was about to say. We could have, on Friday, all we did was graph it on a number line. We did this.
Oh, gotcha.
Okay, that was graphing in 1 dimension. We're graphing in 2 dimensions now. Okay, so in a 2-dimensional, this point right here, that solid circle becomes a solid line. And that shading that happened over here, actually, is that whole thing now.
Oh, wow.
It doesn't show a y value on there, so that's why I'm kind of confused.
Yep.
It's like,
So,
can't it
hey, hold on, pause. Whoever's talking somewhere else, you're not hearing anything that Dylan's saying, which is making it difficult for everyone else to hear it as well. So, yeah, there's no y value, but you're given a coordinate plane. So if it says graph in a coordinate plane, that means an xy axis.
Oh, okay. But if it just says graph, then
Yeah, if it said just graph, you could have graphed it on a number line.
okay, got it.
Yep. Okay, the other thing is, rather than using your arrow to shade, the arrow's pointing to the left, so we'd shade to the left just like we did here. But you could also test this point, 0, 0. When I plug in the coordinate 0, 0, when I put 0 in for x, is 0 greater than or equal to negative 3? Okay, but so if I say is 0 greater than or equal to negative 3, the answer is? It is greater than. So yes, it is. Okay, it's greater than negative 3, so we can shade over 0, 0. If I said no, it wasn't, it's neither, then we'd have to shade away from that. Okay? How many remember doing this in algebra? Okay. Let's see. Everyone show your neighbor your answer for number 7. Okay, so need your attention back up here. Y equals mx plus b. Eyes and ears focused right here. Y equals mx plus b. Here's our b. It's our y-intercept. We go down 2 over 1. Drop down 2 over 1. Okay, and we keep doing that. You have to make every point that will fall on this graph accurate. Okay, so if it's going to intersect the grid in a perfect spot or evenly, then you need to make it accurate. Solid or dash it? It's solid because it's got that or equal to piece in there. So solid. Got our arrow. Now we have to figure out where to shade it. Now once again, you can't always test a point on either side of the line. You can test one over here, any point, or you can test one over here. I always, if I'm going to test, I always choose this point if it's not on the line, because that's the easiest point, 0, 0. If I test 0, 0, 0 and 0, notice when I put 0 into this, what happens? What's negative 2 times 0?
0.
0. It's gone. So is 0 less than 3?
Yeah.
Less than or equal to? The answer is yes. So we shade over here. Now the other route to go, the other way to figure that out is to look at the symbol. What type of inequality symbol is that?
A less than.
It's a less than. If it's a less than symbol, you shade under your line. If it's a greater than symbol, you shade over your line, above your line. Now some students struggle with that. That's how I'll go through it the rest of the year, though, is I'll say, hey, it's a less than symbol, so I'm shading under. The other way to think about it is, here's the y-axis. If you just focus on the y-axis, I need everyone's eyes here, because when you guys have a struggle with this at home and you're freaking out and your parents can't help you and you look back here and you're like, oh, wish you would have said that in class. Dude, I'm saying it right now. Your eyes have to be up, though. Okay? So from dealing with this with students in algebra for longer than you've been living, okay, this right here, when you look at the y-axis, if you think of this area up here as, or down here as smaller versions, smaller numbers, their negative numbers are down that way, and this part up here is your positive numbers. What's the sign read?
Less than.
Less than. Where are your lesser numbers on the y-axis?
Down.
They're down here, so you shade over those lesser values because it's a less than sign. If it was a greater than sign, you'd shade over the greater values on the y-axis. Everyone understand what I'm saying there?
Mm-hmm.
Okay, so on this, just looking at it, are you shading to the greater values or to the lesser values on the y-axis?
The greater than.
The greater, because it's a greater than symbol. So if I'm graphing number 11, I'm going down to negative 1, I'm rising 4, I'm running 5, rising 4, running 5. Once I see my trend, I can go down 4 and over 5.
What if it is undefined? Like straight up and down?
We'll talk about it.
Okay.
Oops, 1, 2, 3, 4. Okay. Solid or dashed?
Dashed.
Dashed, yes. Bless you. Okay. And the greater than symbol says I shade all the big Y values. That's all those values up here. Which if that's the case, if I'm shading all the big Y values, I'm shading above. Now you could still test 0, 0. Will 0, 0 work in this if I tested it?
Yes.
Yes. How do I know?
You just plug in the origin into the x and y values.
If my shading's correct right now, how would I know 0, 0 is a solution? Tell your neighbor. You guys, that's going to be a test question. Tyler?
Because 0, 0 is in the shaded area.
Because 0, 0 is in the shaded area. Therefore, it is a solution. If you wanted to make sure, you could always plug it in. That would make 0 is greater than negative 1. That's true, so it's a solution. Okay, please remember, we talked about it just briefly, but if you had forgotten, if your equation or inequality only has an x in it, then it only crosses the x-axis. If the equation or inequality only has a y in it, then it only crosses the y-axis. And if it has an x and a y in it, then it's going to cross both axes. Okay? Any questions there? All right. Hey, Hannah had a question real quick if it's a y equals equation. So just really quick, if my inequality is y is greater than 2, and I plot that right there, and I want to shade, I'm shading above or below? Above, right? I'm shading the greater values up here.
You didn't make it dashed.
If it's undefined,
Yeah.
so like we did here.
Yeah.
So in that case, think of it like a number line, right?
Oh, yeah.
Okay. All right. Hey, we're going to skip this one for now. 21 will come back to it, possibly. You're not. Okay. Number 24. Let's try some graphs. Without your graphing calculator. None of these you can use your graphing calculator on today. Hey, so as we're going through this, first thing to ask yourself, after you figure out the picture is a V, hopefully you recognize that. How do you know it's a V? Absolute value. Okay. Where is the vertex? So first thing you need to ask is, what is HK? In fact, if I were you, I'd start just writing that next to your graphs. HK is what? Yeah, what's in here with x? Or what makes this thing in here become 0? Well, there's only an x, so it's 0. The k is, what are you adding to the outside? 0. So it's at 0, 0. Hopefully you recognize that as the parent function. Okay? What is the slope? In other words, what is out here? Yeah. 1. So from there, we rise 1, we run 1. Rise 1, run 1. Okay? We keep doing that all the way up. Now hopefully that one's not too bad. That's your parent function. We've done that a bit earlier this year, so it should be a pretty easy graph. We have our Kirchhoff and our total Kirchhoff.
Wait, so there's not enough spaces?
We'll take care of that. We'll get you more. Yeah, you'll need more grid paper.
Yeah, we
Okay. So these are pretty easy right there, right? What happens when you have a negative in front? Tell your neighbor and then graph it. Okay, so our HK value, once again, is 0, 0. Right? We're not adding anything in here that or subtracting, and we're not adding anything on the outside. So we get 0, 0. And since it's a negative, that means our slopes or our graph is opening downward. Okay, one of our goals will be for you to be able to use patterns the rest of the day to graph these absolute value ones. Okay, the first two are pretty darn easy. They're your parent function, the parent function and its opposite. Okay, any questions on that? Okay, let's move on. Let's look at 26. And before we can do 26, let's talk about what the vertex form is. How many of you remember vertex form for an absolute value? Uh-oh. Y equals A, absolute value, B, X, minus H. Anyone going to join in? Plus. Okay. Memorize the form. Memorize what they mean. Okay? HK, right? Now, there should be parentheses right there in order for that to be a true statement. Okay? Y equals A times B. A times the absolute value of B times the quantity x minus h plus k. Now, a lot of times we don't see this. We haven't talked about this part. Okay? But right now, if the kind of rule of thumb is the coefficient of x, the number in front of x, must be a... What's in front of that x right now?
B.
What is it? How many say it's a 1? If you don't see anything in front of a variable, what's in front of it?
1.
A 1. There's a 1 in front of that x. So if it helps you to write a 1 right here, like that has to be 1 in order for it to be in vertex form. Then write a 1 there. Okay? So maybe, to make it a little more clear, put that 1x. Okay? 1 times x minus h plus k. Now 1's a big deal. So maybe draw, I don't know what you have to do on your paper to draw emphasis to this, but do it. Okay? So right now, is this in vertex form? Is it a 1x?
Yep.
Yep. Is there anything out here?
No.
Nope. So here we go. What's hk?
Negative 1.
0.
Good. What makes this 0 is?
Negative 1.
Negative 1. And what's out here?
0.
0. Okay? That tells us our vertex. Everyone put your vertex on your paper. Okay, go to negative 1, 0, right there. What's our slope? Well, in this case, our slope are these two things multiplied together. Sorry. Thank you. Those two things multiplied together are our slope when you're doing this. A times B is your slope. Okay? So in this case, there's nothing out there. So our slope is?
1.
Just 1. So from here, we rise 1, we run 1. We have 1 going out, and then reflecting those points across the axis of symmetry, or for some of you students, you just think, well, it's negative 1 going in, 1 going out. Okay? So that is our... And we got to connect the points, otherwise you have discrete data versus continuous. Discrete versus continuous, and this is a continuous graph. So discrete would just be the points. All right. Tell your neighbor how number 27 is going to differ from 26.
It's going to flip upside down.
Right outside of the absolute value zone.
Okay, so what's that? How's that going to change my graph?
It's going to change the slope.
It's going to change the slope. What's that going to look like? Dylan?
It's gonna flip around.
It's going to flip it upside down. Yep. Negative out here just means it's going to flip it upside. It's going to open downward.
Yeah.
Okay, any questions there? We're about to make it a little more complex. Hannah?
So it wouldn't be a positive because you have the h value is a negative?
It wouldn't be a positive.
Because no. I don't know.
What wouldn't?
I get what you're saying, but I was wrong with the question. Because when you're finding hk, you have x plus 1 and that h is negative 1, right?
Yep.
But I got stuck in the part where it said a times b, which is actually the 1, not the h.
Right.
Okay, so it's just negative.
Yeah, so it's a negative, so it's going to open downward, the a times b. Yep. All right. I want you guys to take a look at number 28. Go ahead and graph it. What do you think it is? Okay, so hk in this case. Inside there's nothing, so it's 0 for h, and k is 1. So we go 0, 1. Slope is
1.
1. So we rise 1, run 1. Okay, so we go through, plot our points, make sure they're accurate, and chow there, and chow there. How many got it? Well done. Tell your neighbor how 29 would differ. 29 different. Cool.
It shifts down 1 on the y-axis from the origin.
Okay, so it's going to be down at negative 1. So the vertex is going to change. So
Oh,
shift
yeah.
down. All right. Want everyone try number 31 now.
Oh, we're getting fancy.
Okay, here we go. H. HK. What's H? New person. Jaden.
0.
0.
Yay.
Thing that makes that 0 in there is 0. X has to be 0. What's K? Yes. Madison. 0. 0, 0. So we're here. Opens up or down? Down. So it's nice to just draw a quick picture if you have to, just to remind you it's a negative. Now, this is my slope, right? Means I'm going down 2 over 1. Down 2 over 1.
Whoa.
So remember that A times B tells you your slope. So this graph should look a little narrower. It approaches infinity quicker if you think of that, or negative infinity at this point. Total. Okay? Any questions on it?
No, sir.
Okay, everyone rate themselves 1 to 5 right now. 5, you got it? 1, you're struggling. Okay, last set, number 36.
Oh, this is really fancy.
See if you can do it. Do it in pencil, please. Okay, here we go. Let's start out. What is K?
K is
5.
okay.
How many agree K is 5? Yep, K is 5. K is the easy one.
Yep.
What's H?
1 over 3.
1 over 3.
1 over 3. 1.
I think it's 1.
I think the easy way is to just say what makes that 0.
Yep.
And when we're doing that, we add 3. We get 3x equals 3. And then we divide by 3. We get
1.
1.
Yay.
Now, the other way to do it is actually to factor in there. You can pull a 3 out. And so K is 1. Remember, it's the opposite of this. K is 1. So we get 1 and 5. That is our vertex. What is our slope?
3.
Parker?
3.
3. It's right here. We rise 3 and we run 1. Okay?
Groovy.
And it is a narrow little guy there. Okay, now
It's a bad easy.
from what we've done today, hopefully you're pretty good with absolute value.
Oh, yeah.
You know, with HK, know what each part means. Okay? If not, if you're like, I don't know what that is, then we need to talk. You'll notice on the bottom part where 36 through 41 says use your graphing calculator, you can just cross this part out. Or with, it should say without. On yours it says with. On mine it says without, but you guys need to not use a graphing calculator, so I'm just crossing that out to kind of show you. On yours, cross out the calculator piece.
We need
Just
to.
graph it.
We need to not.
You need to not use your graphing calculator.
That's great.
Don't use it.
Okay.
Okay.
Okay. Do it by hand. Okay. The other thing is, number 21 we didn't get to. However, you must attempt it tonight. You get credit for attempting it. And attempting it means more than just reading it. 21. Okay? Yes, Tyler.
What do we do with our homework from last night?
We'll grade it tomorrow. Okay?
So,